Right, welcome to our class. This is a continuation of the previous class, measurement, length. So last time we talked about the perimeter. We mentioned that perimeter is a distance around a figure. We had a number of examples for each. We talked about circumference. What is the meaning of circumference? We also talk about arc length. We mentioned what is the meaning of an arc. We talked about the major and the minor arc. We also talked about the formula for getting the arc length, the length of an arc. And just as a small recap for that, we said that perimeter is a distance around a figure. Perimeter is distance around a figure. Total distance around a figure. That is what we said perimeter is. So whichever way the figure looks like, perimeter is total distance around it. And we talked about circumference, and we said that circumference is simply the distance around a circle. Circumference is the distance around a circle. And we said that circumference is given by pi d, or the other formula is the same as 2 pi r. Circumference is the same as pi d or 2 pi r. So this one is diameter, and that one is the radius of this is the radius, this one is diameter. We talked about the arc length, and you say that arc length is same as the angle or theta. Then you just add this formula, pi d. You can even add this one, no problem. These two formulas are the same. So arc length is the angle at the center, then you multiply by pi, then you multiply by diameter. Right. Now, today I want us to talk about area. We talk about area, and have a place to write, have a pen and a book so that you can be able to really make use of this lesson. And area is not our first time to hear about area, so I'll just add to what you've been learning. And I'll begin by talking about the units of area, units of getting area. And in perimeter, we talked about the unit of getting perimeter. We talked about Kenya has dug many dams containing minerals or maji. That you have, this one is kilometers, hectometers, decameters. We have meters, we have decimeters, we have centimeters, we have millimeters. Now, for area, the only thing that is unique here, in area we normally square. So kilometer squared, decameter squared, we have meter squared, we have decimeter squared, centimeter squared, millimeter squared. So we will have a number of examples for this one, how to convert from one unit to another. And just let me pick a quick one. If I want to convert, moving down here, we really you multiply, and moving up here, you really divide values here. So if I pick one of them, if I want to know an area of a value like 1 hectometer squared, this is the same as how many centimeters squared. Now, I will borrow so much from what we talked about length here. We know that 1 hectometer is the same as hectometer is here, then centimeter is here. So 1 hectometer, I am moving how many steps? 1, 2, 3, 4, 5. The same as a number with 5 zeros, that is 100,000 centimeters. So if I want to know uh, um, how many hectometers squared or how many centimeters squared are in 1 hectometer squared, I square this. If I square this number, square means you multiply a number by itself twice. So 1 by 1 is the same as 1 hectometer squared. And what you do here, so here is like I've taken 1 multiplied by 1. So even here I'll multiply um, 100,000, you multiply by itself twice. So if I multiply by itself twice, it will be a number with 10 zeros. This will be 1, 2, 3, 4, 5, 6, 7. Let me write 12 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 centimeters squared. So 1 hectometer squared, you also multiply this one out, the same as 100 centimeters squared. And since I want to convert from hectometer to centimeter squared, I just take this one, just take that one, you multiply by this huge number here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because I'm moving down, I'll multiply. And my answer will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 centimeters squared. So the only difference here, we square, you multiply by itself twice. We have other units, and this is very important for us to know. We have the other units of getting area of a figure, and the key units here is the hectare, the meter squared, and the air. So we have we know that 1 hectare. This one I want you to master it the way it is. It's the same as 100 air is the same as 100 air, and 1 air is the same as 100 meter squared. And also we have 1 hectare. Hectare in other words, in the short form for that, 1 hectare, 1 hectare, or even in capital letters here, is also the same as 10,000 meter squared. Then we have the last one, that 1 acre. 1 acre is the same as 4,046. 4,046.86 meter squared. These are very important conversions, that 1 hectare is the same as 100 air, and 1 air is the same as 100 meter squared, and 1 hectare is the same as 10,000 meter squared. We can have some conversion for that. If I try and pick a number of examples here, I pick an example for this. We have many of them here. I pick unit of getting area. For example, I pick one here, and I'll just do the examples here. Convert each of the following units into the one indicated in brackets. So you convert the units in the stated in brackets there, right? So I'll come and have, for example, I pick this one. I'll pick let me pick in any of them here. Let me pick this one. I want to convert into 5,000 meters squared into kilometer squared. Now, if you go back to the table, we know that 1 kilometer is the same as, if you go back to the table that we drew earlier there, uh, if I come here, from kilometer to meter, moving how many steps? One, two, three. So that is the same as sorry, the same as is the same as 1,000 meter. And what about 1 kilometer squared? So 1 kilometer squared, the same as 1 multiplied by 1. 1 multiplied by 1 is the same as 1. So kilometer squared is equals to this one multiplied by itself. What is 1,000? You multiply by itself is the same as 1 million. This one is meters squared. So this is the one that I'll be using. I will not use this one. This one is the unit for length, but now here you're talking about area. So if I want to convert this 5,000 meters squared into kilometers, from meters squared to kilometers, I'm moving up. And if I'm moving up from my table, I'm supposed to divide. So I'll divide my answer by this value here. 1, 2, 3, 4, 5, 6. So that you have the 3 zeros will go with that 0. So that you remain with 3 zeros here. So this is the same as 3 decimal places. I'll come and write 1, 2. Then you have 3 decimal places. This is now kilometers squared. So that is how you work it out. If I pick one like this one, I can pick one like this one, and I say we know that 1 hectare is the same as 10,000 meters squared. So what about 0.45 hectare? Here I can just cross multiply. I cross multiply. If 1 hectare is 10,000, what about 0.45? So it's the same as 0.45. I'm multiplying by 10,000. Sorry, these are supposed to be 1, 2, 3. Then I just divide by 1. This is the same as, if I divide by 1, there is no big difference here. Same as 45 all over 100. I am multiplying by 10,000. 2 zeros will go with the 2 zeros, so that my answer will be 4, 5. 45 you multiply by 100 is the same as 45. Then I put 2 zeros, the same as 4,500. This is now meters squared. So here we really just do the cross multiplication. All right. So that is how we work out that the conversion of units. I want us to quickly go to a number of calculations here. We try to remind ourselves, how do we get area of different shapes? How do you get area of different shapes here? And especially the one that the common ones that we know. I have a number of shapes here, and I want us to look at them. And I'll be writing the formula. Then we just go through them very fast. Okay. So area of different figures here. We clear this one. The common figures that we know. Area of common figures. Common figures, and I will just go through each and every one of them, and you will be writing down. So the first one, I want us to learn how to get area of a rectangle. Area of a rectangle. We know the properties of a rectangle. A rectangle looks like this. That is a rectangle. And this side is the same as that side. And this side is the same as this side. The longest side, we call it length. Capital L. Then this shorter side, we call it width. We call it W. So, and we know that this side is same as that. This is 90 degrees, 90, 90, we have 90. How do you get area of a rectangle? Area of a rectangle is given by this length, you multiply by this width. So it is as simple as that. That area of a rectangle is length, you multiply by width. The second one, it is a triangle. A triangle, and you know what is a triangle. A triangle is any figure that has three sides. So it can be one that looks like this, provided it has three sides, or the one that might look like that. We have different types of triangles. Uh, but how do you get area of a triangle? Area of a triangle, this side, this lower side, we call it the base. This one we call it the base. Then the distance that is perpendicular, any length that is perpendicular or making an angle of 90 degrees with the base I'll be calling it B. This one is B. This one we call it height. Height. Let me write well. This one is my height. Oh, sorry. Okay. So I call this one height. This distance, this one from here up to here, we call it height. For this one, I just want the distance that is perpendicular to the base. I'll be calling that one height. So area of a triangle is given by a half. You multiply by base, you multiply by height. We will have examples for this, but this is the formula. It is a half base, you multiply by height. Number three is something known as parallelogram. So area of parallelogram program, and parallelogram is simply has is it's somehow like a rectangle but has been tilted. So it has two sides like that, then tilted towards a certain point. Let me draw it properly. I have that one. I have that. So this side is the same as that side. This side is same as that side. This side is parallel to this side, just like the rectangle here, parallel to that side. This side is parallel to that side. Now, this lower side here, we call it the base. The base, then any distance that is perpendicular to the base here, I'll call it my height. So this one is a height. Height can be anywhere as long as is perpendicular to the base. And how do you get area of that? Area of a parallelogram is given by the base. I'll call it like that. Then you multiply by the perpendicular height. And I'm using the word perpendicular because the only way to tell that that one is a height, it must be perpendicular to the base. So it is base you multiply by height, and height must be perpendicular. We say perpendicular height. This one is a perpendicular height. Perpendicular. It must be 90 degrees with the base. Let me write this one properly. Perpendicular height. Perpendicular height. So I'll come here and say this one is perpendicular height. So this one must be 90 degrees. The only way to tell that this one is the height, not to be perpendicular. Then we have the area of number 4, something known as rhombus. Now, rhombus is like a square. Here we didn't mention a square. Rhombus has all sides equal, but now again tilted. This side is the same as that side, is the same as that side, is the same as that side. And this one we call it the base length or the base, simply like the parallelogram here. Then any distance that is perpendicular to the base, this one is what you're calling height. So the difference between rhombus and parallelogram is that rhombus has all sides equal with each other. This side is parallel to this side, and this one is parallel to this side. The formula for getting the area of a rhombus is the same as that of parallelogram. So I'll say that area, it is base you multiply by height, or base multiplying by height. And that is what you have for that. That it is you base you multiply by height. Right. Now we go to the next one, and the next one is something known as another figure that is known as a trapezium. Trapezium. How do you get area of a trapezium? Trapezium. Area of a trapezium. The area of a trapezium is a four-sided figure, so it has four sides, and it has one pair of parallel side. This one has two pairs. This is one pair. This side is makes one pair. This one is another pair. So these are two pairs. These also have two pairs. This side and this one makes two pairs. This side and this one makes another pair. But for trapezium, it is something like this. It can be of that shape. We have trapezium, a shape that looks like that. So that this side is parallel to that. Then this one is 90 degrees. So this one we can call it height of that. It can also be like this, a trapezium, like this. This side is parallel to that side. Then the distance here, we are calling it height. Now, a trapezium can be either something that, as long as it has a pair of parallel, just one pair of parallel sides, then that one is a trapezium. How do you get area of a trapezium? Now, these two sides that are parallel, we call it one side, we call it small a, and we call it small b, the same as this one a, this one is b. So to get the area of a trapezium, area is given by a half height. So you multiply by this height. It can be this one or this one. Then into bracket a plus b. So you take the two parallel sides, you add them together. Then you multiply by the height of that. Then you multiply by a half of from the formula. So you have like that. Now here I can have a number of examples here. Before we go to the last bit, I think I can have a number of examples here so that we have a quick see how the formula is applied. So I will pick some examples. Let me open a new page here. Fortunately, we have one way here. Okay, this one we do not have, but we'll come to this. Let me open a new page here so that we see how we are able to get the area of the shapes that we've mentioned here. Ensure that anytime you are working out, you remind yourself of the formula. Always begin with the formula when you're working out a sum. It is a good habit and it makes your work easier when you learn to write the formula before any working. So always ensure that you write the formula in working out. Okay, I'll pick a number of examples here for that. Um, Let me search for an example that will remind us of what we've done. Good. So find the area. Find the area of the figures below. These are example here. So I'll pick the first figure here. Let me begin with the one in that order. Let me pick as simple as this. We have a figure that looks like this. We have a figure that looks like that. You can guess what that figure is. This one is 32 meters. This one is 8 meters. The second figure is a figure that looks like this. A figure that looks like that. You have a figure that looks like that. And here, this side is parallel to this side. Then you have this one. They are saying this one is 9 centimeters, and this one is 18 centimeters. You have another one. C. Have one that is of this nature. I have another one of this nature. Let me write here down. Sorry, supposed to be something different from that. A bit slanting, I think. Now this side is same as that side. This side is the same as this side. You have it like that. This is parallel to this side. Then this side, all these sides are equal by that. But now this side is parallel to that. This one is parallel to that. Then we have the other one is a shape that, okay, here you have the measurements. You have the measurements here. They have said that this one 90 degrees. Now this one is 5 centimeters, and here you have 12 centimeters also. And the other one is a figure that looks like this. Okay, we have a diagram that looks like this. Have that. You have here is 160 meters. Here you have 200 meters, and here you have 50 meters. So we have a quick one. We go over this. I can also put one that is of this. Of course, we've not mentioned this one, but I know you can. You know what is this? And it's like that. Then here they have put for us 8 centimeters. 8. So I want us to go through this one very fast. So first of all is to identify what figure is this? What figure is this? And if this side is the same as that side, then this side is same as this side, and these are 90 degrees, 9 degrees. Then this one is a rectangle. And how do you get area of a rectangle? Area of a rectangle is the same as you take the length multiplied by the width. And this one is my length, and this one is my width. Therefore, a length of 32 you multiply by 8. And what is your answer? What is 32? You multiply by 8. Can tell me the answer? I believe you've gotten your answer as 256. And because it is in meters, area is measured in meters squared. So don't forget that, because when you leave without the square, it means it's just a perimeter, distance around a figure. Okay, so that is how you get your answer. You can see I've started with the formula, then working out that. If I go to this one, the next one, what shape is this? It has a pair of parallel sides, and this side is the same as that, and this side is the same as this side. So this one is a parallelogram. And how do you get area of parallelogram? It is base you multiply by height. This is a perpendicular height. So the base here, this one becomes my base, and perpendicular height is this one is cutting here at 90 degrees. This one becomes my height. This one is my height. So I'll come and say it is 18. I multiply by 9. And what is your answer? 18 by 9. The answer here is 162, and it is in centimeter squared. So you have like that. What about this one? This one, all sides are equal, parallel sides, two pair. This one is a rhombus. And how do you get area of a rhombus? You said they have the same formula as a parallelogram. So I'll say it is base, you multiply by height. My base is here, my height, because even if the height we put it here, they are the same. This distance, this height, and this height are the same. So it is this one becomes my height. So this is the same as base of 12. You multiply by height of 5. Your answer is what? 60 centimeters squared. Okay. For this one, if this side is parallel to this side, then this one is a trapezium. And how do you get area of a trapezium? It is a half height. Then you take A plus B. And first of all, identify what is A, what is H, what is A, and what is B. Now, this height is the perpendicular distance between the two of them. So this one becomes my height because this one is 90 degrees. Then the two parallel sides, this I can call this one A and this one B. Then I come to my formula here and work out a half. Height here, it is 50. Then you multiply by, open the bracket A, it is 160. Sorry, you add. We are adding here. We are adding 200. So this one, let me extend it here. Let me extend this one a bit here, so that we see that the area here is the same as a half. You multiply by 50, you multiply by, what is 160? You multiply by 200. You add 200 is the same as 360. By 2 and by 2, 25. So what is 25? You multiply by 360. What is your answer? 25 you multiply by 360. The answer is 9,000. Correct. And because it is in meters, I'll say meters squared. That's very true. So you have your answer like that. Let me write here properly. It is 9,000 meters squared. So you have your answer like that. Okay, when you come to this one, the last one here, which is number E. This shape, of course, is a square, and a square, it is side you multiply by side. This is side, and you know that our square has all sides equal. So this one is 8, also this one is 8, this one is also 8. So I'll say 8 you multiply by 8, and the answer is 64 centimeters squared. So that is how we work out the area of figures that looks like this. Always begin with the formula, then you look at what is missing, then you substitute for that. That is how you get the area of figures like that. I want us to go to the last thing, of which now it is the area of a circle. Area of a circle. And let me open a new page for that. Area of a circle. Area of a circle. Area of a circle. We remind ourselves, how do you get area of a circle? Area of a circle. Okay, so the last thing is area of a circle. Area of a circle. Now a circle looks like this. A circle is a figure that looks like that. Now if this one is the center of that circle, then here you have the distance from what we talked about. This one becomes my radius. Now area of a circle, if I want area of a circle, area is given by area of a circle, it is pi r squared. So you take pi, you multiply by radius by itself 2 times. Area, it is pi r squared. That is how we get area of a circle. This is important. Remember, circumference, it was 2 pi r. Get the difference between these two. That here, it is 2 multiplied by pi multiplied by radius. But now here, it is just pi, then radius squared. So area here, we multiply the radius by itself 2 times. We'll see how this one works out. It's good also to remember that in area of a circle, we don't use diameter. If you're given a diameter, we know that diameter is radius you multiply by 2. In other words, that radius is diameter you divide by 2. So if I'm given diameter, I'll have to divide by 2 so that it can apply in my formula here. Right. So let us go to examples here. And in examples here, we will look at a number of examples. Area of a circle. We have, let me begin with the first one. Calculate the area of a circle whose radius is, I'll pick any of them. Let me pick like this one to 2 decimal. I'll pick number D and also number F. 2.4 centimeters, my answer to 4 significant figures. So 12 and 2.4. Let me go 12.5. So they want us a circle has a radius of find the area of a circle with radius So you have the radius is 12 centimeters, and they want the answer to is it one decimal place? Let me confirm that. One decimal place, dp here, one decimal place. This dp stands for decimal place, and the other one is 2.4. I hope for significant figures. Okay, so come here. So the first one is a circle that has a radius of that, and my answer to one decimal place. And number B here, it is a radius of the circle is 2.4, and my answer to 4 significant figures. Okay, now if they want me the solution for this, if they want me to get the area of these circles, let me try to imagine a circle looks like this, and the radius of that circle is 12 centimeters. Now I begin with the formula that area of a circle is pi r squared. So I will come here and say pi is 22 all over 7, unless it's otherwise. Then I multiply by radius. So radius square means you multiply by itself 2 times. So I'll multiply radius by itself 2 times. So there is 1 time, then I multiply by that. So that I'll come and multiply 22, you multiply by 12, you multiply by 12. What is your answer? 22, you multiply by 12, you multiply by 12. Your answer is 3,168. We are dividing by 7. Then I can convert into decimals. So this, if I divide by 7, my answer will become 452.5714. But remember, they want my answer to one decimal place. So the one decimal place is here. But now check the next number. Has it reached 5? Yes, 7 has reached 5. So you add here 1. So that my answer will be 452.6. And it is area. So because it is area, I'll say it is centimeters squared. So you have your answer like that. B, this one was solution for A. B, we are told that the radius here is 2.4. I will come and again say, if a circle, I have a circle that looks like that, then I am having a radius of 2.4 centimeters. I apply the formula area is equals to pi r squared, so that you have pi of 22 over 7, radius is 2.4, you multiply by itself 2 times, so I multiply by 2.4. This is the same as 22 all over 7, you multiply by 24 all over 10, you multiply by 24 all over 10, because it is one decimal, so 1 0 here. So what is 22 multiplied by 24, you multiply by 24. 22 you multiply by 24, you multiply by 24. The answer will be 12,672. Then you divide by, what is 7 multiplied by 10 multiplied by 10? This is the same as 700. 700, and into decimal, this is the same as the value is 18. Sorry. The answer here is 18.1029. And because to 4 significant figures I count from my left. So that is 1, 2, 3, 4. Then I check the next number. Has it reached 5? Not yet. Therefore, my answer will be 18.10. This is centimeter squared. And that is how we get the answer for that. So if you apply your formula, your work becomes easier. Let me check the last example. This was example one. Example one. The last example here. I want to pick the last one and a quick one. Last example, I'll pick from, of course, what we have. Let me pick like this one. These are combined shapes here. I pick, find the area of the shaded regions. Shaded regions, number 3. So I'll pick one like this. So area, here you have a triangle, and I want to get the area of this. I'll draw, now that I can be able to draw it properly, but I can work it here. I think this space is enough, or I draw it. So you have a circle of radius 2. So you have example 2. We have a circle that has a radius of 2 centimeters. Then you have a triangle here. Mine is not perfect. Let me draw it again. I have a circle here, and then you have that one. You have that, and I have that one. This one is 6 centimeters. This one is 6 centimeters. Then my circle here has a radius of 2 centimeters. So they want me to get the shaded region here, shaded region. I want the area of the shaded region, area of shaded region, area of the shaded region here. Now, for me to get area of the shaded region, I need, you can see here you have 2 figures here, and you have one inside the other. For me to get the area of the shaded region, it is the area of the whole of this figure, the bigger one, which is a triangle. Then I subtract area of the circle here. So if I get the area of all of that, then I subtract area of the circle, then I remain in the area of the shaded. So area, shaded area, shaded area is the same as the area of a triangle minus area of the circle, area of the circle. Then I go ahead. How do you get area of a triangle? Is a half base height minus, how do you get area of a circle? Is a pi r squared. Then I come and ask myself, a half, you multiply, what is the base of the triangle? Base here, this one is my base, and this one is my height. So base is 6, height is 6. Then subtract, pi is 22/7. Then radius, it is 2, you multiply by 2 by itself. I believe you can see that one, or I squeeze my work a little bit. Let me squeeze it. I subtract here 22/7, you multiply by 2, you multiply by 2. So that the answer here, by 2 1, by 2 3, this is the same as 18. I am subtracting. This is the same as 22, you multiply by 2, 44, you multiply by 2, 88. Then 88, you divide by 7. 88, you divide by 7. Your answer is 12.57. 0.57. So that if you take 18, you subtract 12.57, your answer will be 5.43. 5.43. And because it is in centimeters, I'll say it is centimeters squared. Centimeters squared. So that is how you work out the area of these different figures. Ensure that you try to do as many examples in each. I believe even here I can give us some questions to attempt here, especially for this one. Let me pick some examples here so that we try to look out. Maybe here you can choose. I want you to attempt here. Attempt number. This is number. You attempt this one. You can also attempt number B. Right. You can also attempt number B here. So you take these three. You attempt them. Let me add one more here. The one that has an instruction. Attempt also number G. So you have the three of them. I can also pick one that has different shapes. Can try to sketch for you. See what you have. So also some other assignments. So add to what we've already given you. I can add some more. So you find the area. Find the area of the following. So please attempt also these ones. Otherwise, thank you so much. Have a wonderful time as you do this assignment, and make sure you are able to inquire more and to do more practice on the same.